computer. Please, class, if you do have any homework questions, either you, as usual, ask me or stay after class, and I will, I will help you with it. So I'm just gonna, don't be shy to ask me any questions. You guys are really quiet. We're gonna talk about your test one here. So your first test is gonna be next Monday and next Wednesday, or depends on your last name. Again, if your last name is A2M, you're gonna take a test on Monday. If N2Z, your test is going to be on Wednesday, October 6th. This is all going to be in class. It's not going to be in Zoom. Currently, I got like 16 or 15 students that is last name A2M that will take the test on Monday. I got 13 students, last name N2Z, that take the test on Wednesday, October 6th. If you want to switch your dates around or let me know, email me as soon as possible. Do not email me on the day of Monday or Wednesday because I will be in school. Don't forget, I have to go to school on that day to do this. So please email me as soon as you can. Don't email me till the last minute. Your time is 12 o'clock to 1:30. So it's in CLA 114. Make sure you have your masks to when you enter the building. We cover chapter 6, 6.1 to 6.6, and 7, chapter 7, 7.1 to 7.3. There are around 10 to 12 questions, and some of the questions has parts A, B, C, D. Your test will be split into 2 sections. So for the first section is where you are allowed to use your scientific calculators, and the other sections is where you cannot use any calculators. So when you and the unit circle will be provided in the test. When I say unit circle, it looks something like this unit circle, but without all this information. So it's going to be a blank unit circle. It will look something like this one. This is the one that you will get in my test, where it's just a blank one. See that? That's nothing. So this is what you will get in my test. And you can use this unit circle. So this is the unit circle. So you can use this in both of your sections. That means you can use it on your calculator and your non-calculator sections. So what we do first is we start with the calculator section first. Then once you are done with the calculator sections, you just come up to the front desk and then you exchange it with your part B, your non-calculator section test. And if you have time, at the end of the test, you can always switch back to the calculator part. So you can always switch back. So make sure you guys know that it will be color coded. And so when you switch back, make sure you put away your, take out your calculator or put away your calculators. And make sure you write your name on both of your tests. Okay, there are 2 tests here, 2 parts. Anyone have any questions for me with this information here? Okay. The one with the calculator section test consists of word problems and graphs. So usually the calculator section test only consists of 2 or 3 questions. So it's not a lot of questions in there. So majority of the question goes to the non-calculator sections. So that's the reason why that I want to start on the calculator section first, because hopefully you can finish this in 10, 20 minutes. If you take more than 30 minutes to do your calculator section test, I will ask you to change it back to the non-calculator section test. So that means to change it back, because otherwise you lose a lot of points. So in your review, there is a letter C next to the question. So the letter C next to the question means the question belongs to the calculator. So if you look at the review that I sent it out to you, this is the review. So if you see a C, the letter capital C next to the question, next to the number, that means those questions belongs to the calculator sections. The one that I crossed out means you do not need to do it, you skip it. So this is so the only calculator section, as you say, is just only this question 2, question 3, 11, 12, and 13. So it's very similar to this kind of questions. So make sure you guys know what to do, how to use you're allowed to use a calculator here. The rest of the test is non-calculator. So all this, as you can look at the review, there's no C next to it, especially this chapter 7. There's no C involved here. So they are not belong to the calculus. So the non-calculus section test is a majority of the questions. It will be like solve error, finding the trigonometric functions giving the conditions, means using the SOHCAHTOA. Find the inverse trigonometric functions, verify identities, like what we're going to do today, and solving trig functions. Okay, so if you look at your review, majority of them is not calculator based. Okay, so these are all non-calculator based. So the review is found on the review I attached in the email. If you need to find, if you misplace it, make sure you go to D2L. So if you go under D2L, go under material, go under content, you will get the review of your test, the same review. So if you look at the review of the test, there is no answer, right? If you look at it here, there's no answer given to you. So if you want to find the answer of this review, you just need to go to your textbook. So when you go to the ebook, your ebook, so let's say this is the ebook in your web assign. You go all the way down till the last chapter. We call it chapter test. So if you click on the chapter test on chapter 6 and 7, don't forget we are in chapter 6 and 7 here. If you go to chapter 6 and go to the chapter test, so these are exactly the same as your review. So if you look at your review on this page, the first question is 5 pi over 4. This is I just got this from your textbook. So this is exactly the same as your review here. See, this is 5 pi over 4. And ABC exactly the same. And if you click on here, that's your answer. Okay. So if you need to know where is your answer is, I would recommend you to look at your ebook, go to the very end of a chapter test, because this is from the chapter test. The review here is from the chapter test. You just click on here and that will be your answer. If you have the textbook, then you can get the answer at the very end. Okay, usually all your answers are at the back of the book. Usually they only give you odd answers, but for the chapter test, they give you both odd and even. So you can actually look at it. So I would recommend either you use your ebook and answers are over here, and use your textbook. The answer will be at the back of the book. So that will be the review of the first test. Anyone have any questions for me with this review, with this test one that is coming up here?
So everything that's on the test will be on the review, right?
Mostly, yes. I will say around 90%.
And then, like, where would the other 10% be?
From your homework, all the notes. Okay. And I want to tell you that it's not going to be exactly the same. So in the test, I won't give you 5 pi, like the first question, I won't give you 5 pi over 4. I will give you something else.
I got a question. I didn't get you right, but so does it show you how to answer the question, or just the answer there in a book?
It's just answer. Yep. If you look at the it's just an answer.
Okay.
So they don't give you the work. So if you need help, you have to talk to me or sign up for the tutoring.
Oh, okay.
They only give you the final answer. But in your test, I want to see work.
Right.
So in the test, I want to see how you get this answer. So in the test, if you just give me an answer like this without showing me any work, you get 0 points.
Right.
So make sure you show me work. Mostly, and then this is for chapter 6. And then if you want to go for the chapter 7, don't forget our test do consist of chapter 6 and chapter 7. So if you want to go to chapter 7, again, you go to chapter 7. And then you go to the very last chapter test. So if you go to chapter 7, again, you go all the way till the last one, chapter test here, chapter 7 test here. And again, the answer is right here. So if you click on it, you will get the answer here. Okay. And as I mentioned, they only give you the final answer. They don't show you the work. So if you need help, talk to me. If you in the test, I do want to see work. Anyone have any questions for me? And don't forget, I will provide you this unit circle. So make sure you guys know how to figure out the coordinates and then figure out which one is sine, cosine. This is something that is not in there. So you have to do it on your own here. You guys all right? And you can get this unit circle in D2L. So if you go to D2L, you will find this unit circle. If you need a copy, just send me an email. I can always email you this unit circle so you can go home and practice it. Anyone have any questions for me before we continue with chapter 7 here? So, no. So I did call you guys to do question 3 and question 4 to try on because we are kind of a bit running short of time for this week because the test is next week. So, and again, class, you only next week you only attend one class on campus. So if your last name is A to M, you only come to Monday. N to Z, you come on Wednesday. There is no homework due on the following week. Talking about homework, forget about that. So we got 2 homework due on Wednesday, which is this coming Wednesday, the 29th. Usually our homework due on Wednesday, right? Every Wednesday, you can tell. But 7.3, this is very important. 7.3 homework is not due on the Wednesday of the October 6th or 7th. It's going to be due on the October 3rd, on Sunday at midnight. The reason why I put this on Sunday is because your test is on Monday. Some of your test is on Monday. So that's the reason why that the 7.3 homework is due on this Sunday at midnight. So not next Wednesday like usual. Okay. And you can tell that there's a big jump from your next homework. That means that the following Wednesday, you almost like what, 17 days, you don't have any homework. So I just point to you that yes, you don't have homework during the test time because I didn't teach anything. You guys take your test. So on the October 13th, you don't have any homework at all. So the next homework you have is the October 20th. So just make sure you guys are aware about the due date here. This is the correct due date. So make sure you follow along. And this is a special one, especially a lot of people will be saying, oh, what's happening? Why is due on Sunday, not Wednesday? This is the reason why, because your test is on Monday. Okay. Questions, anyone? All right. So we're going to talk about this question number 3. Does anyone know how to prove this identity for question number 3 here? Again, proving identity, you have to tell me which side you start from. Is that from the left-hand side or the right-hand side? Okay. Anyone? And then I'll show you what happens to your homework here. So from the left-hand side, okay, yep. So you start from the left-hand side. Ming says start from the left-hand side. Always start from the complicated side. Yes, in your test, make sure you tell me it's the LHS, which is the left-hand side, or the RHS, the right-hand side. So Ming, since you told me to start from the left-hand side, what can you tell me here? What can you do? Anyone? So this is a fraction question. This is over 1. So does anyone know what to do if you have fractions? What do you need to find?
Ri.
Said?
Yes. Ri.
Yes, Said? What do you need to find? Fractions. When you add and subtract fractions, what you need to find? Ming? Said? Anyone? Adrian?
Lowest common denominator?
Yes, you find your LCD. So can someone tell me what is the LCD here?
Could it be 1?
No.
Would it be tangent?
Tangent x, yes, that is a LCD here. We do not need to multiply on the left side because this one already have tangent x. So what do we need to multiply on the right, the second term here? We have to multiply this by what? Tangent x, right? And when you multiply this by tangent x, you also have to multiply tangent x on the top one. And we know that when you multiply tangent x with tangent x, you will get tangent square x. because tangent times tangent is tangent square x. So this is what you need to do first is to, again, this is the hint. When you see addition or subtraction with fractions, LCD, least common denominator is what you find. So since they are the same, we got tangent x here. This one is 1 plus tangent square x. And don't forget, our right-hand side has the tangent x in the bottom. So the tangent x is good, so don't change it. But the top one you see here is secant square x. So can someone tell me what can we do with this 1 plus tangent square x? We have to apply identity here, right? So what identity works on this case? You should know. Anyone? This one is you guys should know. What identity used here to change the 1
Pythagorean.
the Pythagorean. And what's the Pythagorean identity says for 1 plus tangent square x, you get what?
Secant squared x.
Secant square x. Yep. So you will get exactly secant square x, and this is your right hand side here. So make sure you guys know how you do this. This is how you prove identity in my class or in my test for next week. Tell me what side you start from, and then prove it to the right side in this case. Anyone have any questions for me here? We'll do number 4 here. Secant theta. Again, if you do not like theta in your test, you can use secant x. It's fine. I'm not that picky. But in your online homework, if they use theta, then make sure you use theta on it. They are picky. Okay. So for my test, I think I will change all the theta or beta or alpha into x for you guys, so you guys do not need to change it too. So which side you want to start from for question 4 here, left or the right hand side? Always pick the complicated sides. So which one is more complicated for you? It's gonna be the left hand side. This is definitely the complicated side. So can someone tell me what can we do here to make him having secant x? Anyone? Now we cannot use Pythagorean identity on this side because there is no squaring. Okay. And do not do this. Oh, since I know Pythagorean identity, you need square, right? Oh, I'm going to square both sides because when I square both sides, I will get square, and then I can use Pythagorean identity. Do not do this because this is considered solving equations. As I told you, when you prove, you cannot add, subtract, you cannot cross multiply, you cannot multiply, you cannot square both sides like this. So please don't do this in your test, otherwise you get 0. So can someone tell me water here? What can we do here? So see, this is secant x, right? This is already have secant x. So this is good. This is cosine x. Can we change cosine x to become secant x? So we try to make everything as secant x so that we all have the same secant x here. So we can change this, right, to secant x. Can someone tell me what can we change to secant x for cosine x here?
Isn't that 1 over secant?
So the rest is going to be the same, secant x minus 1 minus we're going to use the reciprocal identity for this case. This is 1 over secant x. So what you find out here is they're all in secant x already, which is good news. But we got fractions down here. See the fractions? So as usual, when you add and subtract fraction at number 3, what do you need to do when you add and subtract fractions? You have to find what? You have to find the LCD. So what is the L? Just concentrate on the denominator. Don't look at the top one, just the bottom part here. What is the LCD for this 2?
Secant x.
Secant x. So what we do here is like what we did in number 3. So we're going to multiply this with secant x because that is what is missing. This fellow, we do not need to because they are the same. They have a secant x denominator. So what we have in this case is secant x on the bottom. And this one, we have secant x minus 1. Okay, so this is secant x minus 1. The top one is going to be, I just rewrite this. I didn't do any changes of it. So I just rewrite the top one. So the bottom one is the one that we do, and very similar to number 3. Now, you guys know what happens when you have a number over by a fraction. Do you guys know how to do this? For example, you guys remember how we do this? This is the same as what? 3 divided by 1/2, right? Which is the same as what? 3 times, you flip this one, right? You guys, you know what I'm saying here? What? This is the same thing. So this is the same as secant x minus 1 divided by this, okay? But as you know that you can always change that division to become multiplication. But what happens to the denominator here? Remember last time?
You flip it.
You flip it. So this one, you go up, the secant x will go to the top. You flip-flop it, secant x minus 1 will be in the bottom. Now, can someone tell me what we're going to do here once you flip this? Anything can be canceled? You find
Secant x minus 1 can be canceled.
Yep. So this is cancelable because one is top, one is the bottom. So what you left is just what? Secant x. This is the same as your right-hand side. You guys all right here? Anyone? So this is how we do this. So we do have like sometimes the level of difficulty is easy, like number 3. If I say 1 to 5, 1 is easy, 5 is hard. Number 3 is considered level 1 or 2. Number 4 is considered level 2 or 3. So sometimes you can go to level 4, 5. In the test, I won't give you level 4, 5. I will probably give you to level 1, 2, or 3. Maybe 3.5 is the highest I give to you. I do not want to give you higher than 3 is because it's going to be a bit difficult for you guys. So that's the reason why I keep it really simple for you guys. I mean, it's still tough, but I don't want you guys to do the level 4, 5 because it's going to be really difficult. Okay. And you will spend a bit more time on it. So usually I tell students for the test, if you spend already 6 minutes, 5, 6 minutes on the question and you still did not get what you want, then I will recommend you to move along. Okay, so stop looking at it and then move to the next question. Otherwise, you are just wasting your time thinking over it. Okay, so we do question 5 here. We have fractions again. There are addition here. Again, which side should we start here first? Left or right hand side?
Left because it's more complicated.
So but you can tell the majority, we always start from the left hand side. So in the test, I think I mean, sometimes on the right, it's not always left. So this is a fraction again on the left hand side. You have to find the LCD, right? What is the LCD in this case?
Is it cosine x?
No. It will be cosine x times what? 1 plus
1 plus sine x.
Yes. Usually, like example is if I give you number like this, how do you find your LCD here? You take these 2 and multiply, right? So this is the same thing. Mostly if you see fractions and they are not common, the LCD will be this one times that one. So it would be cosine x times 1 plus sine x. So it's very similar to the fraction that you guys did with numbers 1, 5, and 1, 6. There's nothing in common between 5 and 6. You just multiply 5 times 6 is 30. That's your LCD. So that's how you figure out your LCD in this case. So what is missing on this is 1 plus sine x. So you need to multiply this also by 1 plus sine x. Since this already have 1 plus sine x, if you multiply by 1 plus sine x, this is 1 plus sine x squared because you duplicate this. This one you need to multiply with cosine x, and you have to multiply the cosine x on top. So what you have is cosine square x because you got cosine times cosine. So you get cosine square x. So what we have in here is your denominator will be cosine x, 1 plus sine x. Now, what you need to do here is you have to FOIL this fellow out. So go ahead, class. I want you to FOIL 1 plus sine x squared. And square means you have to multiply this by itself again. So yes, I want you to FOIL this one out and tell me what is it. And I will have a cosine square x back there. Okay, go ahead and FOIL 1 plus sine x squared, which is this one. So you know how to FOIL this. Again, I will keep your denominator as your LCD, cosine x, 1 plus sine x. And you notice that I did not distribute the cosine x inside. So this is a hint I always tell students is when you do fraction like this, you do not distribute, you keep it as a factor form. So keep it as this. The reason why is if anything in common on top, you can cancel with it. Okay, but once you multiply in, you have to factor it out. So you're kind of, doing back what I do not want you to do. So just leave it as that form. That's your LCD form. That's a factor form. Anyone? Foiling of this, what you get? You guys know the FOIL, right? We get 1 plus what?
Ming said it in the chat.
Oops, thank you. Someone in the chat. Yep. Thank you, Ming. So it's 1 plus sine x. You got 2 because you got 2 of them and then sine square x. So it's 1 plus, I'm gonna write it here. 2 sine x, thank you, Ming. Plus what? Sine square x. Yep. Thank you. Now something can be performed here. So once you FOIL this, yep, that is correct. Can someone tell me what can we do here?
Wait, why do we put 2 sine x plus sine squared x?
Well, that's 2 sine because you FOIL one and then you FOIL the other one. You get sine x. And then you find this one, you got another sine x, that's why you got the 2 in there.
Okay.
And then you got sine square x and the other one. Yep, that's why you got the 2 sine x in that case. So anyone, what can we do with this top one? Usually this top one is the one that we're looking for. Anyone?
Can you cancel out the 1 plus sine x?
And we cannot cancel out 1 plus sine x here is because this is factor already. This has not been factored. So in order for you to cancel stuff, it has to be factor first, like what we did in the, this is called factor because you take out something out. Okay, so once you factor, then you can cancel. Well, we can do something on the top one. Anyone wants to? Okay, don't cancel this. If you cancel your 1 plus sine x here, you're not gonna get you will get not 0, but not full points. You did some work here, so that will be wrong in this case. Anyone? We're gonna use identity. Can someone tell me where is identity we can use on the top here? This one. Can someone tell me what is this one? It's sine square x plus cosine square x. That is a Pythagorean identity. Yes, Ming. And what is that is? That is 1. This is equal to 1. So when you combine this, you got how many? 1 plus 1, you get 2. So you will get 2 plus 2 sine x. And what can you do with this 2 plus 2 sine x? Again, you cannot cancel because as I told you, you need to do factor first, right? So can we factor something on this fellow? We can factor out the 2. And when you factor out the 2, what you get?
1 plus sine x.
You get 1 plus sine x. Now, as I mentioned, you can only cancel stuff if you factor ahead of time, which we did factor. Now the 1 plus sine x can be canceled. So what you left in this case is 2 on top and cosine x on the bottom. But as you look at your question, your right-hand side is 2 secant x. We got the 2. So can someone tell me how you change this cosine x into secant x?
Reciprocal identity.
Reciprocal, because this is 2 over this is 1 over cosine x. So this is your reciprocal identity. So that's why your answer in this case will be 2 secant x. And that's the same as the right-hand side. So this kind of questions is level 3 or 3.5. So this is the hardest type of questions you will get in my test, because this is the consider level 3. Again, I'm not going to give you level 4, level 5. This is 3.5, 3 to 3.5 level. So make sure you guys know how to do this kind of questions. Tangent pi over 2 minus x. Again, I changed the data to become x times tangent x equals to 1. So this is question 6 here. So can someone tell me which side should we start first? The left-hand side or the right-hand side of the equation? You can tell that the right-hand
Left.
side, left, don't do the left because your left is only have 1. So, oh, sorry, my bad. Yeah, sorry, your left-hand side. So you are correct. Sorry about that. Your left-hand side, because this is more complicated than the right-hand side. You got 1. So, so if you look at this, we do have an identity on this friend of yours here. Okay, so this is identity that we did not use a lot. Usually we use the quotient, the reciprocal, and the Pythagorean identity. But that the one that I boxed up just now has another identity. So can someone tell me what identity is this tangent pi over 2 minus x, the one I boxed out in orange?
Is it cofunction?
Yes, this is the cofunction. So every time when you see pi over 2 minus x or 90 degrees minus x is a cofunction. And which cofunction are we using here? So this is a cofunction. Which one? It's gonna be this one, right? Because again, 90 degrees pi over 2. So what is tangent pi over 2 minus x is? It's gonna be what? That is gonna be a cotangent x. So this fellow will be the same as cotangent x. But you still need to multiply this with tangent x. Now, what can we, again, we need to get 1. That's our main goal here. So can someone tell me how can we change this to become 1? This is very straightforward now. Anyone know
By
what?
using the quotient identity.
Which one?
The quotient.
We can use quotient. If you use quotient, then you're going to use both of them, right? Okay.
Yeah.
So one way is to use quotient. So you figure out what is cotangent x and tangent x using quotient. So you can use that. What's the quotient identity for cotangent x?
Cosine over sine.
Mhm. And what is tangent x for quotient?
Sine over cosine.
And what happens here?
They would like equal 1.
Yep, they all cancel out, become 1. So the cosine will be canceled with cosine, sine will cancel. So you can use a quotient identity to do this, which is the right-hand side here. Anyone have another example, another way to do this besides using quotient here? Yes, you can do that. This is right. You can also use reciprocal because cotangent is a reciprocal of what?
Tangent.
1 over tangent, right? And then you multiply this with tangent x. And what happens to your tangent x in this case? They will also cancel out. You get 1 in this case, which is the right-hand side. So again, class, you can use quotient identity here, or you can use reciprocal identity. It doesn't matter which identity you use. As long as it's equals to 1, I still take it. Okay. You guys all right here?
So there's a few ways to prove some of the
yes.
answers.
Yes, there are few. And those who are really smart actually like this, as I told you, this is a very difficult one, right? There are one way that is taking you only like 2 steps to do it instead of this 3-4 steps, but I'm not sure you that. I recommend you to be safe. This is the safest way to do it. If you do the quick one, then you have to be really, you have to really think outside the box. I do see some students can do that, which is kudos to those. So I was sometimes, oh, this is good. So as long as there are multiple ways to do it, as long as it's correct and you use the correct identity, yes. Okay. Yep, there are a lot of ways to do this kind of. Some students ask me, do I need to tell you, do you need to tell me what identity do you use here? I would recommend you to tell me, like, like all this, I use PI, RI, QI. So I would recommend you to do that. But if you don't do it, it's fine. As long I kind of know what you're doing when you do that. But I would strongly you to do it if you have time. If you don't have time, then don't do it. Okay, it's up to you. But I can't figure. I can read through your stuff and I can tell. And sometimes if I don't get it, I will ask you, what identity are you using here? Make sure you know which identity you're using. So if it's a familiar one like Pythagorean identity, then yeah, I can figure it out. But otherwise, I probably will be like, I don't get what you're doing here. So now 7. So anyone know what side should we start from? The left or the right hand side for question 7?
Left.
Okay, left. Now I want to point out to you guys that let's say you do left hand side, you do halfway and you stuck, you get like 1 over sine x example. Okay, you stuck. Then you continue. Okay, you know what? I'm gonna start with right hand side, and you do, and you still get 1 over sine x. Can you just leave your answer like this? Oh, you know what? Since this is 1 over sine x, this is 1 over sine x, I'm done because they are the same, right? Can you do it like this? The answer is no, because if you do it like this, I won't give you half the point because you do halfway here and then halfway there. So what you do is if you do this, what you do here is you just read this backwards. So if you continue reading this backwards and write it down here, you will prove it back to left hand side. This is another way that I always tell my students is if you do left hand side, you stuck, you get start on the right hand side. And as long as the left and right side get the same trigonometric function here, you just need to write it backwards and you will get back the left hand side. This is another trick I tell my students. So so this is something sometimes I have that dilemma too, because I was I don't know what to do here. I stop here and I start from the other side and then I figure out, oh, actually it's this way. So you just read backwards, just write it backwards, you'll be fine. All right, so those who say left hand side, what can we do with left hand side? What kind of identity we can do on the left hand side?
Reciprocal.
Reciprocal, okay, so we're gonna use reciprocal on this one, which is 1 over sine, right? And cotangent next, anyone, what identity should we use for this fellow? Now we don't want to use reciprocal because if you look at here, they're all in terms of what? Sine and cosine. So we're going to use quotient identity here. Can someone tell me what is a quotient for cotangent?
Cosine over sine.
Cosine over sine. Okay. Now the good news is you do not need to find LCD here because the denominator is the same. So you get sine x here and 1 plus cosine x because you do not need to use quotient in this case. You don't find LCD here because the denominator is the same. So you just add your denominator. But we need him. So that means is sine x over 1 minus cosine x, not 1 plus cosine x over sine x. So what do we need to do here? Anyone? Do you see the hint here? This is 1 plus cosine x, and this is 1 minus cosine x. What is that called when you see one, when I say 1 plus minus, 1 plus cosine 1 minus, see the plus here and minus there? What do we call that? If you remember, this is back in last section 7.1. Anyone? So back in section 7.1, what was that friend of yours? We call that as what? The conjugate. Remember, you got a plus. What's the conjugate? It's the minus. So we multiply this with the conjugate. Remember this one, number 12. Okay. So what we're trying to do here is kind of the same thing on this question here. Is this one got a 1 plus, this is 1 minus. So now we're going to do the conjugate. So we're going to multiply this by the conjugate, which is 1 minus cosine x. And you multiply this by 1 minus cosine x. Okay, so usually the conjugate last time is on the bottom, but this time it's going to be on the top. So when you multiply this with the conjugate, now the denominator is still the same. I do not want to multiply this in. I just leave this as sine x. 1 minus cosine x. What we need to do on the top part here is you have to FOIL this fellow out because it's a multiplying. Go ahead and FOIL what you have on top. This is not a difficult foiling. And tell me what you get when you FOIL the top. So the hint I always tell students, if you see 1 plus and you get 1 minus, usually it's a conjugate, this one. So you will get.
Is it 1 plus? Oh, no, man.
It's
Someone put it
1
in the comments.
minus cosine square x, okay? Not plus, because the plus and minus give you negative. Do we have an identity for this 1 minus cosine square x? What identity is that? Square, so we know it's Pythagorean, right? Identity. So what is 1 minus cosine square x? Pythagorean says sine square plus cosine square equals to 1. This is Pythagorean. So what is 1 minus cosine square? So you move this over there. What do you get? Anyone? What is 1 minus cosine square x?
Would it be sine squared?
This is sine square x. Yep. So this will be sine square x. So this will be sine square x. We are very close because look at the denominator. What can we do with this one and the one on the bottom? What can we cancel? We can cancel the sine x, and sine square, when you cancel, you still get sine x because one of the sine. This is like sine times sine. So one of the signs cancel. So what you left in this case is what? The top one you get is sine x. The bottom one you get is 1 minus cosine x. And this is your right hand side, which is the same as this one. So this kind of question, like number 7, is going to be like level 4, 5. This is the one that you won't see in my test, where you need to multiply by the conjugate. Usually in my test, I won't give you that tricky one that you need to multiply by its conjugate. So this is like level 4 here. So level 4-ish, yeah. So I won't, this one, no. Okay, it's a bit difficult. So we're gonna do the next one here. Tangent x plus cotangent y over by 10x cot y. And this will be tangent y plus cotangent x. And don't forget, y and x are not the same. The variable x and the variable y is different here. So anyone know what's to do with this fellow, number 8? Again, what side you need to start from, the left or the right? This is a level 4. Not this one. This is easy. Anyone? We're gonna start from the left-hand side. And this is what we call as a monomial. Why I say this is a monomial is because this thing is only one term. So every time when you guys got a monomial, we can always split this into 2. For example, is if you have 1 plus 3 over x, this is a monomial in the denominator. You can split this to become 1 over x plus 3 over x. This is the meaning when I say split into 2. As long as this is one term, monomial, you can do that. So, so what we do here is the same part, is because that is a monomial. So we'll split this into 2. So you will get tangent x over by tan x cot y, cotangent y, plus, and then you do the same thing here, cotangent y over by tan x cot y. So once you split this into 2, we can cancel. So this side you can cancel the tangent x. This side you can cancel the cotangent y. So what you left in this case is 1 over cotangent y. And what you left here is 1 over tan x. And if you look at your right-hand side, can you tell me how you change this to become this? What kind of identity do you use? Yep, so both of these we will use reciprocal identity. And if you use a reciprocal identity, this fellow will become tangent y. And this fellow will become cotangent x. And that will be the same as your right-hand side. Now, this is not tough, okay? But you need to know the trick. And the trick here is, this is a monomial, which is one term, and you will split this into 2 sides. Okay, this is the trick that make sure you guys know this trick. Very, very important trick. And only work when it's monomial. If you have a binomial like cotangent x plus cotangent y, don't split it into 2. Okay, so if your bottom one is like that, cotangent x plus tangent x plus cotangent y, do not split it into 2. Okay, or minus. Okay, this is 2 terms. Don't do that. Okay. If you have this, if you have a plus or minus here like this, usually we'll do the conjugate. Okay, so if you want, that's my hint, is usually I will do the conjugate if you have a plus, if you have 2 terms here. So 2 terms, usually we do conjugate. This is for 2 terms. So if you have 1 terms, monomial, we split it to 2. That's mostly the trick that I will thinking about using. Okay. So again, class, you need to practice because I've been doing this a lot. So that's why I know a lot of tricks behind it. So that's why I would recommend you guys to practice this. The best way to practice this is please do the homework from the textbook, because the one on your online homework, they don't do the same way as we do. Is fill in the blanks. So if you do your online homework, it's a fill in the blank. And I can tell you that in your test, it's not fill in the blank. It's very similar to what you did in this note here. Okay, so make sure you guys practice. So let's take a look at number 9 here. Tangent 3x equals to tangent x secant square x minus tangent x. So again, tell me what side you start from, the left or the right hand side. Anyone? Now, it will be really difficult for you if you want to start from the left-hand side, because your left-hand side is only have tangent 3x. So this question, we will start on the right-hand side. Okay, so it means we will start on this side. So what can we do on this right side, anyone? What can we do on the right side here? Anyone? What can we do on this? Tan x secant square x minus tangent x. Anyone? But in common, we can actually do what here? If you look carefully, this one has what in common here on the right hand side. You can factor out, you can do factoring here. And what can we factor here? Anyone know what to factor out here? So you can factor tangent x. And what happens when you factor tangent x? What you get? When you factor tangent x on this, what you get? You will get secant square x minus 1. So when you factor tangent x, you will get secant square x minus 1. And can someone tell me what is secant square x minus 1? What kind of identity is this? Okay, there's a square involved, so we will use a Pythagorean identity. And if you refer to Pythagorean identity, it says that 1 plus tangent square x is secant square x. So can someone tell me what is secant square x minus 1? So this will give us, yep, looks like Ming knows what to do. So this will become tangent square x. And we're gonna multiply this with tangent x. So what happens when you multiply tangent x, the orange one, with the tangent square x, the one we use Pythagorean identity? So this you will get tangent 3x cube x. And this is your right hand side. Or your left hand side, sorry. Because your left hand side is tangent 2. So this is how we do question 9. Again, it's not difficult. It's mostly factoring. So very important class. Something that you guys need to practice on. Okay. The last one is question 10. Sine 4x plus cosine 4x equals 1 minus 2 cosine square x plus cosine 4x. So so this is the one that we have. I just write it here. This is also tough. So probably let me think of, I don't think, yeah, this is also tough. So so we're gonna talk about how do we do this one. We will do, let me see. We're gonna start from the left hand side here. Okay. And we're gonna start from the left hand side here. The reason why we start from the left hand side is because if you look at this, all this is in terms of cosine. This is all in terms of cosine. So this side you got cosine, this is sine. So we need to change this in cosine. And if you change that in cosine, then everything is in terms of cosine. So how do we change this in terms of cosine is, we will write this as sine square x. So sine 4x is sine square x times sine square x. So I just duplicate this twice. Then plus cosine 4x. So the cosine 4x, we don't change it because this is already have cosine 4x in here. So what we need to do is we change the sine 4x to sine squared times sine squared. So that if you multiply this, you get 4. With the sine square, you can actually use your Pythagorean identity for it because it's a sine square. We cannot use Pythagorean for power 4, but for power 2 we can. So power 4 we can break it out into 2 power 2s. So this will become 1 minus cosine square x because 1 plus sine plus cosine equals to 1, so sine squared. And then this is also 1 minus cosine 4x, cosine square x, sorry. So these are the same, so I just duplicate, but the cosine 4x at the back, I just rewrite it, so we don't do anything with it. And the reason why is because this side is all in terms of cosine. And what you need to do in this case is you have to FOIL this follow-up. When you FOIL this follow-up, yep, go ahead and FOIL it out. What you get here. So FOIL it out. And you will still have the cosine 4x here. That one is, we cannot do a lot of things on it, but we will. And you can tell you once you do the Pythagorean, everything is in terms of cosine here, which is what we want. So anyone know what is the foiling for this fellow? So make sure you know how to foil. Is 1 minus what? 2 cosine square x, because you got 1 negative cosine square x and you also got another negative cosine square x. You got 2, and then you plus cosine 4x, because 2 negative become positive. Cosine square times cosine square is cosine 4. And what can we do at the last 2 terms here? Because they are like terms, you can combine them because they are all cosine 4x. So this will give me 2 cosine 4x. And the one in the front, you just rewrite it. So this is 1 minus 2 cosine square x plus that. And this is your right hand side, which is this fellow. 1 minus exactly the same. So this is how we do question number 10. This is also around level 3-ish, like 3.5 for question 10. So so you can get either question 10 or you can get either like you won't get question 7. That one is a bit more difficult. So so class, this is how we do proving of identities. Very, very important, as I mentioned it. So something that you guys need to practice. It's not something that you guys, oh, I can do this. You need to practice this. And I can guarantee you that a lot of students cannot do this in my test because they don't practice enough. How do you practice this? Is do this homework. Okay, so do your online homework and then practice on this homework. This is something that I will also very stress, very concentrate on. Okay, very big. So we're gonna move on to the next section, 7.3. So so in 7.3 we do what we call as solving trigonometric equations. So the difference between 7.3 and 7.2 is 7.2 we are proving or we are verifying the identity. We are not solving. In 7.3 we are solving. So if you look at this, it says solve. So again, when you do my test, read the question carefully. Sometimes I say solve and sometimes I say verify, and there are 2 different things. If you solve on verify and for solving you verify it or you're proving it, you're doing the 2 opposite way, you get 0 in the test. So make sure you read the instruction. Are we solving or are we proving? Same, so make sure you guys read the instruction really carefully. So every time when you solve a trigonometric equation, it's like solving normal algebraic technique, like combine like terms, factoring, move, now you can move the sine x over there and you can divide by 2, like solving equations that you guys did in your algebra, your normal algebra class. This one you might need to apply identities here, your trigonometric identities. So it's like very basic solving equations like what you guys did in your algebra class. However, when you solve this, you always came up with, instead of x equals to 2 or x equals to 3 or a -1, you always will come up with a sine x equals to 2 or cosine x. So instead of doing x, you got sine, or you got the trigonometric came out. So what you do here is that you need to watch carefully. These are a few notes that you need to watch out here is make sure you know that the trigonometric function has its own coterminal angles, depends on the reference angles and quadrants. Why I keep on stretching on this one is because that example is that if you where's my unit circle? If you have just quadrant one is for all trigonometric are positive. Quadrant 2 is only sine and cosecant. Quadrant 3 is tangent and cotangent. Quadrant 4 is cosine and secant positive. So these are the very important quadrants. So if you got cosine theta, let's say cosine theta equals to 1/2. Then when you move over on this side, your theta in this case, because you're solving for theta or x, you will get the arc cosine of 1/2. And since this is a positive, can someone tell me what quadrant is cosine is positive? Now 2 quadrants. Anyone? What quadrant is it?
1
And
and 3, I think.
all students take calculus. 1 and
4.
4. So that's the reason why that this first thing that I talk about here is you need to watch your quadrants because what is positive on that. And then you need to figure out the reference angle. So this is where you figure out using this. Cosine is your X or your Y, your quadrant 1, because it's 1 and 4, right?
X.
X. So which one of these give us 1/2? Because the question is asking for 1/2, right?
Pi
So
over 3.
which is that
Pi
30?
over 3.
Pi over 3. Yep, we use radian. So pi over 3, and which one is the corresponding to pi over 3 in quadrant 4?
5 pi over 3.
So this is what we call as the reference angle. Is they're all over 3. So so your answer in this case will be pi over 3 and 5 pi over 3. This is your answer in this case. Okay. So this is the meaning of when you solve this, you have to know the reference angle, which is the pi over 3, and its own coterminal, like 5 pi over 3, that is the quadrant 1 and 4. So this is the one that you need to watch out for it. And also watch out for the periods. As you guys know that this sine and cosine or tangent cosine can go forever because the domain is all real numbers. So any numbers goes. So that if the question is asked, so you have a lot of answers. So the answer that I provide to you here is where your theta is between 0 to 2 pi. Means that you only go one revolution or one cycle or one full circle or one, one Faris. And so what happened is that sometimes your answer, I want it to be infinite solution. And when I want this in an infinite solution, means that I want it forever. That means it's not just one revolution or one circle like this. I want it to be like multiple revolution. So if you want multiple revolution, you just take this value that you find out in here, pi over 3, and you just add 2k pi. And then same thing here, 5 pi over 3 plus 2k pi. So you have to read the question carefully. If the question wants it in just one revolution, means 0 to 2 pi, or they want it in an infinite revolution, means to keep on going. And the difference is that if you know your one revolution, for infinite, you just add 2k pi on it. That means you keep on circle around. We use 2k pi is because of your of the period. So for sine, cosine, secant, and cosecant, we will use the period is 2 pi. So in this case, you will have to put 2n pi or 2k pi. It doesn't matter, it's 2n pi. Watch carefully on your homework. It is n. I think they use n or sometimes k. So watch carefully. They will tell you what variable you use. For me, I'm not very picky. You can use 2n or 2k pi. So this is only for sine, cosine, secant, and cosecant. But if you have tangent and cotangent, the period is pi. So you will add n pi or k pi in this case. So what does mean in this case that if you have cosine here, then for the infinite one is you add 2k pi. But if you have a tangent one, then you just need to add k pi or n pi in this case. I'm not very picky which one you use, k or n, whichever you use. How do you know that if a question is asking for infinite or for just 0 to 2 pi? You have to read the question carefully. For example, is like this question does not say anything. This is going to be infinite solution. Okay. Okay. So means you have to add 2n pi or n pi. But once a question gives us like this, find a solution in the interval of 0 to 2 pi. This is only for one revolution. So that means that you do not need to add n pi or 2n pi. You just use the pi 3 and pi 5 by 3. So make sure you guys read the same thing happens in your test. I will say, give the solution into one interval, like 0 to 2 pi. And sometimes I want it in like just solve the equations in range. That means I don't tell you what is how many revolution. That means this means it's infinite. So make sure you guys know the difference between 1 and infinite. So that's the thing that I point out here. Okay. Next we have is when two or more equations occur the same, two or more functions occur the same equations, make sure you make the equations equals to 0. And then we always use factoring or identities. So what do I mean here is if you have like here, if you have sine x and cosine x, you got two different ones like this. Make sure we always make them equal to 0. So we move this to the left, either we move the 3 cosine square x to the left side, so you make it equal to 0. And we will apply identities since they are squaring, probably Pythagorean. And then factoring will be involved. And then after that, you can make them equal to 0 and then solve. It's like solving equations. So this is what happens when you got like something like number 2, like we got two sides like this. If that equals to 0, then you don't need to worry about like this one. Yeah, like number 7, 8, because they have both sine and cosine on both sides. So you might need to make it equal to 0 in this case. The square, you can also square each side of the equation. That means square both sides of the equations. But watch for extraneous solutions. Does anyone know what's meaning when I say extraneous solution? So you actually have to check your answer. Okay, you do have to check. Extraneous solution means that it's the solution, but when you plug in and check it, it does not work. So when you square both sides of the equation, and the reason why we square both sides is because of Pythagorean, because every time Pythagorean requires squaring. So if you don't see any squaring, you want to make it square because you can apply Pythagorean pi. So but however, when you solve, you can use pi and then you try to solve everything. The answer that you get is not always the correct one because you have to plug in and check it back for extraneous solution. I would suggest you that this squaring both sides of the equation is your plan Z. Plan Z means the last resort. So if anything does not work or you try a few ways and you say, you know what, it's not square, I can use pi. I'm going to square both sides, but make sure that once you square both sides, you've got multiple answers and you have to plug in. If you have 4 answers, you have to check all 4 of them by plugging it into your equation, like checking your, when you do your when you solve the equation, you get x equals to 2, you have to plug it back and check it. Same thing happens here. So you do have to check your answers if you square both sides. And this will be all. This is your last resort that I will, last part. So if you, I would strongly suggest you not to use this. The reason why is because checking your answer is a bit more, you spend a bit more work, but that is a way to do it. I would not really strongly suggest. So I won't, for me in this class, I will really strongly not suggest you to do before. Okay, but if you want to do it, it's fine. Work, lots of work. Okay. 5. When you solve for multiple equations, this is very important. So this is for multiple angles like u/2 or 3x. You solve the equations that you have, and then you have to divide or multiply so that you will get x by itself. And then you divide and multiply it, you do need to include the period. This is the, I'm going to put like special 3 dots here. Means this is very important. So this is only happens when you got multiple angles. What is qualified as multiple angles is like when you got like 3x like this. When you have x, 1x, it's not considered multiple. This is also x. The square does not involve, so this is also considered singular. This is also considered like this is a multiple because of 3x. This is also considered multiple. You got 2x. This is also considered multiple. You got half. So those with we have 3x or x over 2 or something else is all singular here. You need to watch out for your how we solve this. Let me give you an example. So this is a singular. This is called a singular here because it is only 1x or 1 theta. Okay. So what happens when you got multiples? This one I'm showing to you here. So that means instead of cosine theta, I will have cosine 2 theta. Again, I don't want to use theta, I just use 2x. It's the same thing as half. So what we do is exactly the same as number 1. We move the cosine over, become arc cosine of half. That is exactly similar as what we did on number 1. And then you figure out what is arc cosine of half. You tell me that I got 2 answers. One of them is quadrant 1, which is pi over 3. And then one of them is quadrant 4, 5 pi over 3. So it's exactly the same. This is what you have as your answer in number 1, right? If I want to write from 0 to 2 pi. But unfortunately, this is not 1 theta, 1x. This is 2x. And we are solving for x. We are not solving for 2x. So what you need to do is you need to divide this by 2 in order for you to get x. So when you divide this by 2, you will get pi over 6. So now we get x. We'll get pi over 6 here. And you will get 5 pi over 6. However, if I want your answer in 0 to 2 pi, you will get more answers. The reason why you will get more answer is because of this. It used to be 0 to 360, but once you divide by 2, because you got 2x, you divide by 2, your 0 to 360 will cut into 0 to 180. But my question wants it to 0 to 360. So what you need to do here for this kind of question is they're actually, you have to double it. So usually you will get 2 answers here because one is quadrant 1, one is quadrant 1, and one is quadrant 4. But once you get a 2x, you will have 4 answers in this case. The reason why you got 4 answers is because it used to be quadrant 1 and quadrant 4, but once you divide this by 2, your quadrant 1 will become quadrant 1, your quadrant 4 will become quadrant 2. So you have another 2 more that is in quadrant 3 and 4 because it is you have to hold. That means you have to take 2 circles and divide by 2. You will get 360. So what happens to, how do you find the other 2 is you have to add something. So what we do need to add here in this case is, this is something, because of the reference angle is pi over 6. So if you look at your unit circles, this is pi over 6 and 5 pi over 6. So they all are over 6. So the next one that we have in this case will be 7 pi over 6 and 11 pi over 6. So because all of them have pi over 6 as your reference angle. So this answer that you have in this case will be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So this is special now. So this is something that I want to point out to you guys is how we know this is once you got a double angle, your answer will be double. You still have 2, you will get 4 answers. What happens when this 2x is a 3x? Then you do not have 4 answers, you will have 6 answers in this case. So for example, it's 3x in this case is pi over 3 and 5 pi over 3. So in order for us to do this, we have to divide this by 3. So you will get pi over 9, because 3 times 3 is 9, and 5 pi over 9. And don't forget, this is just 2 answers. As I mentioned, you need 6 answers. Again, how do we do this? Now, over 9, if not, you cannot look at your unit circle because we don't have over 9 in your unit circles. So what we do is look at the pattern. So this is 1, right? The next one is 5. So in order for us to get 1 to 5, we add 4, right? No. Can we do that? No. So no, don't do that. For us to do this is you have to use the infinite. So this is a better way to do it. So so this, I'll show it to you the best way to do it. So if this is 3x equals to this, 3x equals to this. So you're gonna divide this by 3 to get rid of the 3, like solving equation. So you divide this by 3. You also need to divide this by 3. So in this case, that's why I will get pi over 9 and 5 pi over 9. So what you need to add in this case is 2k pi over 3. So how do we figure out the next one is you put k equals to 1. So this is how we do it. Okay. Yeah, I'm going to take attendance now. So please put in as your present in this case, attendance in this case. So what is going on is you have to put k equals to 1. So this will become pi over 9 plus 2 pi over 3. So the next one we have in this case will be this fellow plus 2 pi over 3. And then the same thing happens on the next one is 5 pi over 9 plus 2 pi over 3. So in order for us to do this, you have to make them the same denominator. So I book it over 9 because they all have LCD is 9. So this will become 7 pi over 9 because 1 pi plus 6 pi is 7 pi. So the next one we're gonna have in this case is 7 pi over 9. And this one I do the same thing. I multiply this by 3. This is also over 9. This is 6 plus 5. This is 11 pi over 9. So the next one we have is 11 pi over 9. And don't forget, this is just 4 answers, and you will get 6 answers. So the other one that we're going to use is when k is 2. So this is k is 1. So now we will plot k is 2. So when you got 3x, you have to go through 3 revolutions. The first revolution, you get these 2 answers. The second revolution, you get this. The third revolution is where you get pi over 9, plus it's pi over 9, plus when k is 2, you will get 4 pi over 3. And this is the same thing. You will get 5 pi over 9 plus 4 pi over 3 because now your k is 2. So this only happens when you got 3. Okay. And again, you need to find the LCD, which is 9. You multiply this by 3. So you will get 13 pi over 9. So the next one that we have in this case will be 13 pi over 9. And then the last one, same thing, you multiply this by 3. This is also over 9. And this will become 12 plus 5. This is 17 pi over 9. So you will get 6 answers in this case. So this is something very difficult. I didn't say this is easy. This is something that you need to watch out, especially when you got multiple angles like 2x or 3x. You need to do something like what I just showed you here. So this is the one that I'm pointing out here. Watch out for multiple angles. That is the difficult part that a lot of students kind of struggle in the test. The last thing we're going to talk about here is watch what I want. Do I want 1 revolution? Do I want infinite revolution? So this is as I told you how we figure out which one is 1 revolution. Do you want in degree or do you want radian? I want to point out to you that in my class, we only use radians. So do not give me your answer in degree. So same thing in the test, same thing in your homework. Everything we do here is all in terms of radians. And you just need to figure out, are they 1 or infinite revolutions? And usually the last thing I'm pointing out here is I want your answer in exact. So what I mean by exact value is something like this. So if you look at this, you can use your calculator to do the arc cosine of 1/2, right? So if you use this one, you can use your calculator to do it. Okay, and you will get wrong, I can tell you that. If you use a calculator, because this is in radian, so what you do is you change your degree to radian, and you do the arc cosine of 1/2. Remember the arc cosine, you have to do the second shift. So when you go arc cosine of 1/2, you will get this 1.047. Okay, this is wrong. Okay, so don't use this arc cosine of half, right? In radian form is this 1.047. I do not want this. This is not exact. This is the same as pi over 3. So if you take pi divided by 3, you will get the same thing. So this is what I want, not him. So that's the reason why that I don't allow you guys to use calculator in this case, is because when you use your calculator to do the arc cosine of 1/2, you get all bunch of decimals, but I do not want that because I do want it in the exact value. So when I ask for exact value, means I want it in like this, like pi over 3, pi over 4, pi over 6, not as this 1.047, something like that. I will mark you wrong in your test if you give you this answer. Okay, so this is something that I will ask my students to do it. So make sure you guys, this is tough. This is actually quite difficult compared to, so you can tell that the material is tough. Chapter 7 is actually one of the most difficult chapters here. So let's take a look at some examples here that you guys know. So the first question that we have here is asking for an infinite solution. So we will have, this is 7.4, 7.3. We have cosecant x plus √2 equals to 0. So every time when you want to solve an equation here, we are solving for x here. So like solving equations, so the first thing we're going to do here is we need to get rid of this 2 so that x is by itself. So the first thing we need to do is move this over there. It's like solving equation. So cosecant x in this case is -√2. And then in order for us to get rid of the cosecant, we move it. But because when you move it, it's the inverse of arc cosecant. We don't do arc cosecant. We only do arc cosine, arc sine, and arc tangent. So we can change this cosecant to become the reciprocal, which is sine. So this will become sine x. But if you change this to become reciprocal, then this has to be flip-flop. So this will be 1/√2. Okay. So the reason why we change it to become sine is because we learned the arc sine, arc cosine, arc tangent. We don't do the cosecant one. So if you want to change it to the reciprocal, make sure you flip-flop it. Can someone tell me what is this is if you rationalize this? I don't want the √2 in the bottom. Anyone know what's the rationalize of this? This will be √2/2. And you have a negative. Don't forget the negative carry along. And then the sign will move back to the other side. So now we got the arc sine of it. So can someone tell me for sine, what quadrant is negative? For sine, what quadrant is negative?
Would it be 3 and 4?
Yep. So now we need to look at your unit circle again. Concentrate on quadrant 3 and quadrant 4. Sine, is that your x or your y value? Sine is your
Y value.
y value. So if you look at your y, this quadrant 3 here, which y value give us negative square root of 2/2? Which y value give us that? This fellow, right? Which should be what? 5 pi over 4. Can you tell me which of these also give me in quadrant 4? Give us negative square of 2/2 in y value. That will be what? 7 pi over 4. So your answer in this case will be 5 pi over 4. That is in quadrant 3. And 7 pi over 4 in quadrant 4. Okay, because this will give him negative. Because you want, the question is asking us for infinite revolutions. So what you need to add here is 2n pi. or 2k pi. Doesn't matter, it's n or k. So the reason why you use 2n pi is because your sine is 2 pi revolution. So this is your answer in this case. So what we do here, this is the thing, solve like x, like, move things around, and then move, if it's sine, become arc sine, if it's cosine, arc cosine when you move it. And if you have a 1, you do not have to worry about dividing by 2. And then you need to figure out what quadrant is this, follow positive or negative, depends on your value. Then if it's a positive, you will have 2 quadrants. If it's a negative, you have the other 2 quadrants. And then if it's an infinite, you have to add 2n pi. But if it's just 0 to 2 pi, your answer is just the 5 pi over 4 and 7 pi over 4. So those are the 2 types of questions that 2 types of answers that we have here. So this is how we do this kind of solving equations here. So when this is the end for today's class. So when you come back on Wednesday, we will definitely continue this. This is a bit difficult. The reason why it's a bit difficult is because you need to go back to what quadrant it belongs to, and you probably need to use back your unit circle here to figure out what is your angle that we're talking about here. Okay, and again, we don't use the degree, we use the radian. Okay, all right, that's it for today's class here. So if you guys have any questions, please stay back. If you do not have any questions, you may go. We'll definitely continue 7.3 on Wednesday. Anyone have any questions for me?